ever higher quality and ever more automated manufacturing sites. Products are becoming more advanced and thinner, so measuring parts packed into them becomes more difficult. As loose or inclined parts on PCB will cause assembly problems, high-precision height measurement of parts is needed to detect them. Different materials and conditions, such as narrow area, coarse surface, transparent film, mirrored surface, curved surface, and inclined surface are used for objects. Sensors must be mounted in narrow spaces where they will intervene with positioning cameras or dispensers in machining and assembly processes. Different types of triangulation laser displacement sensors are required for different materials. Even when sensors are selected to suit the materials, the sensors cannot measure profiles accurately due to variations in measurement values and measurement failures. The sensor heads are also too big to install in a narrow space. The confocal fiber displacement sensor using the white light confocal principle can stably measure any material to reproduce accurate profiles. The small sensor head can be installed in a narrow space. The white light confocal principle uses coaxial light to measure based on color. This section gives a brief explanation of this principle. Multicolor white light is transmitted from the light source through the fiber cable. The white light transmitted to the sensor head is focused at different points for each color using the OCFL. Only the wavelength of light that bounces off the surface is transmitted to the controller, and other wavelengths are not received. The wavelengths transmitted to the controller are diffracted by the spectrometer and focused at different points on CMOS. This position information is used to measure height. Omron's ZW confocal fiber displacement sensor is the industry's most popular white light confocal displacement sensor. ZW can provide pinpoint measurements. Curved or inclined surfaces can be measured precisely. We will introduce you to some of our technologies that enable ultra-high precision inline measurements. When the conventional laser displacement sensor measures the height of an electronic chip, the waveform is distorted due to the effect of excessive reflection. This results in a measurement error. When the ZW measures, the waveform is not distorted because only the light reflected from the measurement point enters the pinhole. The measurement is stable and precise. The laser displacement sensor with a large diameter spot cannot measure a gap between electronic chips accurately. ZW with a small diameter spot provides pinpoint measurements. ZW offers a variety of sensor heads with a very small spot diameter to suit your measurement conditions. The square-shaped straight type can be used for high-precision profile measurement of solder on substrates. The pen-shaped straight type can be mounted on the side of a small nozzle. The pen-shaped right-angle type is ideal for height-restricted spaces. ZW measures transparent objects of down to 15 micrometers thickness by separating the light reflected from surfaces. The conventional laser displacement sensor cannot stably receive light. Thanks to 3 times higher angle characteristic than triangulation and wide measuring range, ZW can stably measure vibrating objects. ZW is ultra-lightweight and ultra-compact. Its size is only 1/8 of previous laser displacement sensors. A single conventional laser displacement sensor needs to be moved to measure inclination during camera module assembly. Multiple ZWs installed in a narrow space enable one-shot measurement. Measurement cycle time can be reduced by 90% or more. Low-profile right-angle sensor heads can be installed in height-restricted spaces. The sensor head has no electronic parts and indicators that generate heat, so heat does not affect other devices and measurement values.